Hello classmates, let's learn this lesson, Low Frequency Electronic Circuits, Chapter 5, Negative Feedback in Amplifier. Okay, today we're going to learn Chapter 5, Negative Feedback Amplifier. This chapter is divided into 5 main sections. Let's focus on section 5.1, 5.2, and 5.4. Section 5.3 and 5.5 are for students to learn by themselves. The first negative feedback from an amplifier was American called Blank, invented by engineers or scientists. He worked early at a company called West Power, 25 years to Bell Laboratories. He mainly studies how to eliminate amplifier distortion. In the process of studying this topic, for the first time, he proposed the following: such an amplifier with negative feedback. He first applied for a patent 37 years later and authorized it. Negative feedback is widely used. It can be said today that almost all circuits have negative feedback, including amplifier negative feedback theory. From the earliest electronics to various fields of industrial economy, this chapter mainly introduced the influence of negative feedback on the performance of amplifier, analysis methods, and stability problem. First, let's talk about 5.1. Basic concept of feedback amplifier. What are the components of a feedback amplifier? A feedback amplifier is the signal that outputs the amplifier, partially or wholly through a feedback network, return to the input of the circuit, and adjust the input signal. The resulting closed loop is the feedback amplifier. This is a block diagram of the feedback amplifier. Previous chapter 4 basic amplifiers we've learned. We use this A to represent. We will output the basic amplifier, X out as input to the feedback network. Enter the following feedback network KF. Output KF of feedback network. As part of the basic amplifier, let input Xi' with feedback signal. Then the original input signal Xi interacts with XF. Generation yields a net input signal. The Xi is used as input to the basic amplifier. Pre-entered the basic amplifier, a closed loop made up for this, what we call a feedback amplifier. Xi, we call it input signal. X out is XO. What we call an output signal, XF is a feedback signal. F is feedback for feedback. We process the net input signal in X. That is to say, Xi' equals X minus XF. It's a net input signal. Feedback is how the system behaved in the past. As a supplementary signal, return to the system to control future behavior. This is called feedback. Feedback, the correlation between these signals, we have defined some new symbols. Previous gain we called the gain of the basic amplifier. Now we call it open loop gain. It is defined as the ratio of the output signal to the net input signal, what we call a basic amplifier. Open loop gain expressed in A, because the output of the basic amplifier is Xg. Then the basic amplifier output is X out, so X out is better than Xg. This is the gain of this basic amplifier, what we call open loop gain. Feedback coefficient is the output of the feedback network, ratio to input signal of feedback network. The output of the feedback network is just this XF. The input to the feedback network is X out, output X out of basic amplifier. It is also an input to the feedback network. So the output XF of the feedback network compared to the input X out of the feedback network, we define it as KF, called the feedback factor. Closed loop gain refers to the output of the entire system. X out is the most basic input to the whole system. Initial input, we call it a closed loop gain, when the X out is greater than this Xi is. So, because Xi close to V equals X minus Xf, so the Xiit is equal to the net input signal SIPA at feedback Xf. So we will put this Xi in the closed-loop gain. The input signal is the sum of the net input signal and the feedback signal. So, according to the open-loop gain above, it is equal to Xf over X feedback factor equal to Xf over Xout. So let's say in the denominator, divide all changes over him by Xf and Xout is divided them by X. So this one above is open-loop gain. So what about the denominator below? It becomes 1 plus Xf, and the feedback factor is higher than X, the feedback factor Xi. If we multiply one more time on the denominator of our molecule, see what Xout says. The denominator of the molecule is multiplied by the words of Xout, so Xf is higher than on the molecule. The denominator is this Xout. It becomes a feedback factor. So, the Xo on the molecule, T becomes an open-loop gain compared to this Xi. So this formula, Xf is better than Xi. It multiplies one Xout by the same denominator. It becomes open gain A, multiplied by the feedback factor Kf. So if we take this A, multiply the feedback factor Kf to define a new variable, so this variable is what we call F, feedback depth. Feedback depth equal to 1 plus open loop gain multiplied by the feedback factor. Then the product of the open loop gain and the feedback factor, we define T as T. What does T equal? Just now we said T equals Xf over Xi. It is also equal to the open loop gain multiplied by the feedback factor of the feedback network. So it should be the entire loop. The output Xf is greater than the net input Xi of the entire loop. So this T is called loop gain. That is, the closed loop gain equals open loop gain ratio of feedback depth F, or closed loop gain equal to open loop gain A over top 1 plus loop gain T. These expressions must be relatively simple to calculate. But when you first get to touch these symbols, you need to write them down. Feedback depth and development gain. The relationship between closed loop gain we see. That is, if you have a basic amplifier introduced, after feedback network, entire closed loop gain constructed by feedback network is Xout better than Xi, equals the open loop gain of the previous basic amplifier, depth of feedback above. Greater feedback depth, the smaller its closed loop gain is, that is, after the introduction of the feedback network, has some influence on previous open loop gain values. Generally speaking, the deeper the feedback, the greater the F. Explain this feedback network, the stronger the impact on circuit performance. Let's take a look. How to calculate feedback closed loop gain. Closed loop gain is defined as the output of the whole system is proportional to the input Xi of the whole system. So it's also what we just calculated, equals 1 plus open loop gain multiplied by the fraction of feedback factor open loop gain. This definition is called the basic relationship of the feedback amplifier. It's the one that fits the definition of this chapter. Various types of closed-loop feedback amplifiers. What about the basic amplifier inside this one? This is the basic amplifier electricity we learned earlier, where the feedback amplifier it just satisfies such a one-way condition. That is, I feedback the signal from the network can be used as input, act on the basic amplifier. But this amplifier it does not have a feedback network from this output port. The basic amplifier is only subjected to impact of the net input signal or input port. The basic amplifier has no direct feedback effect. It does not have an Xout from the input port, past basic amplifier. Then on Xi is such an impact. This is unidirectional. Only Xi passes by. Basic amplifier and gets X out. The same thing. Feedback networks are also output only. X out as input to feedback network. Then an XF is generated from the feedback network. Act on the output as a feedback network. X on the input side of the basic amplifier. No signal exists. Output port through feedback network, which is the port on the side of the XF. As input then, from the feedback network to the right of the feedback network. Then act on the output port. There's no such reverse process. This is called a condition that must be unidirectional. Satisfies such a one-way condition. This feedback depends on the nature of the feedback. We define it as a positive and negative feedback. So-called positive and negative are the polarity of the feedback, so I know it works. The basic amplifier signal is called the net input signal. The net input signal is equal to the initial put signal. Subtract feedback signal XF. So, if XF is negative, it might be negative or positive. It has enhancement, but all in all, if the XF is weakening the input signal, make the Xi scheme signal smaller than the input signal. So we say it's negative feedback. If it is the role of XF, make the net input signal Xi greater than Xi. It's the input signal. We call this feedback positive feedback. Positive feedback and negative feedback, you should probably be in your normal life. You also heard this concept, touching a lot in nature. There are many examples of this. What are the characteristics of negative feedback? Negative feedback has the effect of automatically balancing the system. Lower alpine field valley. It keeps the system in balance. It has a stabilizing effect. Improves the performance of the amplifier. For example, for a particular reason, suddenly increases the input signal of a basic amplifier. So what about the increase of the basic input signal? Then amplified by a basic amplifier. Output signal S out is also increases. The increase in X out after passing through the feedback network make this feedback signal XF also increase. The increase of XF decreases the net input signal Xi. Xi apostrophe equals input signal Xi minus feedback signal XF. So, an increase in XF means a decrease in the net input signal Xi. After the basic amplifier has amplified Xi tweezers, X out gets smaller. After introducing the feedback network, we found that if there's a sudden increase in output after this feedback network, there's also a trend towards smaller output. So it has a feature of automatically balancing. So of course, you saw it earlier. There's a loss in the automatic balance of this negative feedback. That's the gain of this feedback, equal to open loop gain divided by feedback depth. It costs less gain. However, gain is easier to achieve in electronic circuits. I changed the magnification of this amplifier. Changing its gain to easier to achieve, but it's not easy to keep the whole system stable. So relatively, its negative feedback brings this to our system, auto-stabilization. So negative feedback is in the entire electronic circuit is very widely used. It is essentially impossible to exist in the actual complex circuit. It does not use one of these. So positive feedback is also useful. Make this small signal get stronger and stronger. But one drawback is that it's like a nuclear reaction. 1 changes 2, 2 changes 4, 4 becomes 8, 8 becomes 16. It does not make this device particularly stable. Many are used in oscillators, the classic of morality in ancient China. A visual analogy of positive and negative feedback. Negative feedback means making up for deficiencies. The way of having lost access and make up insufficient. Then the positive feedback is to make reach richer. Take the lost money without money. The human past is equivalent to the positive feedback. Only the icing on the cake lacks the charcoal in the snow. It's about deficiencies and excesses. So what about that? To further understand the positive and the negative feedback. Okay, this is the end of this class. Thank you.